Hello, I'm Fauwaz Hanbali with the Water Management Systems Division at HEC. I'm going to talk to you about HEC-DSS and gridded data management. This is the first part of the presentation, focusing on what are the primary gridded data and supported coordinate systems in HEC-DSS. In another part of the presentation, we'll take a look at how gridded data is stored in HEC-DSS. We'll finish up the presentation highlighting some of the helpful tools in HEC-MetVue, which is a specialized program for visualizing and editing gridded data. So let's get started and talk about gridded data sources and support coordinate systems in HEC-DSS. In this part, we'll look at the primary data sources that we in the Corps of Engineers depend on from the National Weather Service. And we'll go over three primary coordinate systems supported in HEC-DSS. Gridded data is required for hydrologic and hydraulic modeling, and HEC-DSS supports several data types, in particular precipitation data, which is a primary input for rainfall runoff modeling, and temperature and snow data too, for snowmelt runoff modeling. Like the precipitation grid on the left and the temperature grid on the right, the gridded data products typically have nationwide extents, and they are available from the National Weather Service. Our main data sources from the National Weather Service are the National Center for Environmental Predictions, NCEP, the River Forecast Center's RFCs, and the National Digital Forecasting Database, NDFD. They all provide precipitation, temperature, and snow data, among other types of gridded meteorological data. NCEP provides the initial weather model outputs, while the RFCs provide updated quality-controlled versions of those products. And a nationwide mosaic of each RFC forecast product is available from the NDFD. There's also a special center in the National Weather Service that produces gridded snow products. The center is called the National Operational Hydrologic Remote Sensing Center, or NORISC for short. And their snow data simulation system, SNODAS, produces important initial condition snow products, including snow water equivalent, SWE, and snow depth and cold content. To facilitate data access for hydrologic and hydraulic modelers in the Corps, as part of SWIMS, our Corps Water Management System, we have a service called Cumulus. Cumulus collects National Weather Service products from various sources and provides on-demand HEC-DSS data downloads. Those come with clipped extents based on selected area of interest in the Corps. Cumulus data downloads are possible through the Cumulus site, as well as from the SWIMS CAVI and HEC-MetVue desktop applications. Now let's talk about the supported coordinate systems for gridded data in HEC-DSS. First, the National Weather Service's products, especially precipitation data, typically use a HRAP coordinate system. That stands for the Hydrologic Rainfall Analysis Program. HRAP grids are based on the Polar Stereographic Coordinate System with grid resolution of approximately 4,000 meters by 4,000 meters. The HRAP system in HEC-DSS covers the contiguous United States. It has an origin that is located at the southwest of San Diego, with a pair of column and row indices of 1 and 1. And all other locations are identified with indices 2, where the column number increases in the east direction and the row numbers increase in the north direction. There's also the Standard Hydrologic Grid, SHG. This was established by HEC in 1996. SHG is based on the Albers Equal Area Coordinate System because it preserves area more accurately than HRAP, especially over large mid-latitude areas like the contiguous United States. And that's particularly important for precipitation volume estimates. In HEC-DSS, the SHG grid columns and rows are applicable only for the contiguous United States, and SHG supports a number of resolutions, varying from 10 meters by 10 meters to 10,000 meters by 10,000 meters. In SWIMS applications, 2,000 meters is the most commonly used resolution. The third supported coordinate system in HEC-DSS for gridded data is UTM. That's the Universal Transverse Mercator Coordinate System. UTM provides the most flexibility to represent data outside the contiguous United States, like Hawaii, Alaska, and Puerto Rico, or anywhere really in the world. UTM HEC-DSS grids are also supported by HEC-MetVue and HEC-HMS. Before I finish this part of the presentation, I want to highlight key milestones in the past 30+ years in terms of both the advancements in meteorological products out of the National Weather Service and advancements in HEC-DSS and related tools. So gridded data support in HEC-DSS started in the early 1990s when the WSR-88 NextRad radar network became operational. The radar network provided spatial precipitation measurements throughout the U.S., which made it possible for HEC to develop the Maude-Clark distributed rainfall runoff transformation method. In the early stages of radar, the spatial variability of rain was usually captured fairly well, but the accuracy of depth measurements was lacking. So the River Forecast Center started producing ground truth gridded precipitation products like Stage 3. And at the same time, the use of interpolated grids of precipitation started growing in the core. And that was possible thanks to HEC developing the Gauge and Terp utility, which is a utility that generates interpolated gridded data using point measurements from precipitation gauging stations. Then around 2003, 2004, NORISC's SNODAS model became operational and provided gridded snow data. Corel, the Corps of Engineers Cold Regions Research Lab, developed a utility for converting SNODAS data to HEC-DSS. And by 2016, HEC and Corel developed Cumulus, and that was to make precipitation, temperature, and snow gridded data in HEC-DSS format more easily accessible and usable in the core. And especially applications of rainfall and snowmelt runoff modeling. Throughout the years, the National Weather Service's meteorological data products grew substantially to include more than just precipitation, temperature, and snow. And data formats evolved quite a bit through the past few decades. From the legacy XMRG data format to the latest incarnations of NetCDF and GRIB data formats. And finally, around 2016, HEC developed HEC-MetVue, which supports working with all kinds of meteorological variables. And it also allows for creating interpolated grids with its Met and Terp tool, which supersedes the Gauge and Terp utility. HEC-MetVue offers tons more features too for the processing, visualization, editing, and writing of grids, working with a variety of data formats, NetCDF, GRIB, and of course, HEC-DSS. This is the end of the presentation. If you have any questions about our software, need some help, or looking for additional training, please check out the links below, and thank you for your time.